In this part of our lesson, we're going to do univariate analysis. So when we say univariate analysis, we're going to understand the pattern of our variables. And when we say the variables here, we are actually referring to the numerical variables. And let's first review what these numerical variables are. So we have these variables: the customer lifetime value, the income, the monthly premium auto, the month since last claim, the months since policy inception, the number of open complaints, the number of policies, and the total claim amount. Of course, not all of them would be subject of our univariate analysis. And so earlier in our previous lesson, we talked about the statistical summary of these numerical features. So this is actually a part of univariate analysis, but in this lesson, what we're going to do is we're going to have a deeper understanding of the distribution of these variables. So first and foremost, what we're going to do is we're going to import these packages. This one is to have the colors of our graphs, and this one is to just format the presentation of the value. So let's execute this. And also the random seed here is just 42, but of course in your case, you can also choose any seed you want. So here. Now we are going to analyze first our target variable, which is the CLV, or the customer lifetime value. This one is to have the subplots, the two plots, which is for the distribution and the box plot distribution. Here in this part is that what it does is it just bins the different values. So we have n here, it is the count of each bin, and of course the bins, and then we have the patches, which is for each rectangle of the bins. Of course, we group our data, but of course in this case you can also choose any scalar you want. But of course you also have to see to it that the result would be nice. Then this is for the graph presentation, for the labels of our graph. And so let's execute this, right? Now we have the result. So as we could see, we have the CLV distribution of the different values of the CLV that we have identified so far. And as you could see, it is very skewed to the right. And of course, because of this kind of skewed or skewness, then we can really say that there are a lot of outliers in our dataset. And using this box plot distribution, we can clearly see what these outliers are. So the question here is this: what are we going to do with these outliers? In identifying whether or not to include outliers would really depend on this question. Does these outliers really influence our analysis? So the question is being answered by going back to the domain expertise. So that is why having the domain expertise is really very important in doing some analysis. It's not that you're going just to omit or delete all these outliers when you see the data, but you have to ask yourself first the influential factor of these outliers. So in our case, we are not going to remove these data points, which are outliers, because they are actually very influential to our analysis. So sometimes you also have to set the threshold upon which you're going to identify the outlierness of a certain data set of values. Let's identify the skewness. Of course, we have already seen here in this case the distribution, but it's always better to identify the skewness. So as we can see here, it is a 3.08 something. So which means it's really very skewed to the right. So that's the meaning of that. So when it's very near to zero, it is becoming more normal, and the distribution is the bell-shaped distribution. So when it's really zero, then it's perfectly normal. Now let's go to income. So what would be the distribution of income? So we're going to use the same codes here. Let's execute this so we would know the distribution. Okay, so there you are. So we actually don't have any outliers. And as you could see in this case, 0 is really very big. And we have the I mean, the distribution of the different values apart from 0. It's almost even. Now let's identify the skewness. So let's see, what is it? So it is a 0.27. So it means that it is actually nearing to normal, and we don't have any issue of outliers in this numerical feature. Now let's move on to the next one, which is the monthly premium auto. Let's execute this, and so we would see, right, we have in there. It's also very skewed to the right, and we also have a lot of outliers. Let's check the skewness. There you are. We have 2.11 or 12, just to round it off. And then we have the month since last claim. So we have this distribution. So as you could see, of course, we don't have any outliers, and the data is really more beautiful. It's more beautiful because the distribution is nearing to normal. Now let's check the skewness. This 0.287, so it's good. The distribution is really good. And also, let's execute this. This is for the months since last inception. Let's execute this. Or anyway, before I forget, here we have the colors that normalize. So in this case, we actually normalize our data set. So we could have a full range presentation of our color map. So we have this, and we don't have any outliers. So let's check the skewness. Okay, so our skewness is really very low. It's almost 0.0441 something. So it's really good. Now, let's have the total claim amount. Let's execute this. There you are. So we also have a lot of outliers, and this one, there are really a lot of claims as far as this particular bin is concerned. So it's skewed to the right, but not as skewed as the former ones we already have identified. So as you could see in the box plot distribution, we do have a lot of outliers too. And let's execute the skewness. So we have 1.66, just rounding it off. Right? So as you could also see in the box plot distribution, we could see all the median and the maximum and the minimum values of each numerical feature that we have analyzed. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.